All right, everyone. So part 2 of your notes is all about percent yield. So percent yield is the percent ratio of the actual amount of product created, so actual product created, compared, I actually need to write down all the words, created to the theoretical amount or calculated amount. And so it measures the efficiency of the reaction. So if you are supposed to create 100 grams, but every time you do the experiment, you're only creating about 60, then there might be something going on with your experiment that you can tweak to increase the efficacy of your reaction. And so that's why it's such a useful calculation. It helps us calculate its efficiency. If the percent yield is less than 100%, it means that there was wasted reactants that did not get converted into products. And if the percent yield is higher than 100%, that means more product was created than is actually able to. And so that means that an error had to be made. You can't actually make more product than your chemical reaction says you can. So that means something went terribly wrong in your experiment. And so a fundamental principle for this concept with percent yield is the law of conservation of matter, which states that matter cannot be created or destroyed. So it cannot be created or destroyed. It can only be rearranged. So our formula to calculate percent yield is our actual yield. So this comes from the experiment divided by our theoretical yield. So this is calculated, using stoichiometry, using our T-charts, all multiplied by 100%, which I guess I could have written that on the definition lines that we have here. So it's calculated. The theoretical yield is calculated using T-charts and the equation, using our mole ratio and such. And then the actual yield is what was produced in the experiment. Oops, forgot the word was. What was produced in the experiment. Okay, so let's look at a couple of examples. All right, so example number 1. A group of students were doing an experiment to react copper with silver nitrate as seen in the chemical equation below. So we see that we have copper with silver nitrate, and it's reacting to produce silver nitrate, and it's producing copper nitrate. So they calculated that 169 grams of silver could be isolated if they began the experiment with 50 grams of copper. So they're saying if we start off with 50 grams, they calculated. Now that's a key word. If this number is calculated, that means they're telling you the theoretical yield. Theoretical yield is what's calculated. I'm pretty sure I just spelled that wrong. So this is our theoretical yield of silver. So they're saying we should be able to produce 169.7 grams of silver if they began the experiment with 50 grams of copper and an excess amount of silver nitrate. So that means you have so much, you don't have to worry about it. However, they said they were only able to isolate 122 grams of silver. So we have this much calculated, and 122 grams of silver is what was actually created. So they want to know what is the percent yield of the experiment. So our formula, percent yield is our actual, so our 122 grams divided by our theoretical 169.7 grams, all multiplied by 100%. And when we do this in our calculator, remember 122 needs to go in the calculator first. And then you should get 71.9%. 71.9%. And since we're given two different numbers, this has 4 significant figures, 3 significant figures, we're going to use 3 significant figures in our answer. So our percent yield was 71.9%, which if some of you got that on a test grade, you'd be happy, and others of you would be distraught. So, percent yield is whether or not that number for an experiment is good or bad is kind of dependent on, what your expectations are. So let's look at example number 2. So it says a group of students was doing an experiment using the same equation as example number 1. So it means we're still using that copper and silver nitrate equation. It says, however, in their experiment, they began with 75 grams of silver nitrate and 45 grams of copper. So let's just kind of rewrite it here. So we have copper plus silver nitrate, and it's producing silver plus copper nitrate, which we didn't need to do it last time, but I'm realizing now we didn't actually balance it. So you would need a 2 in front of both silver compounds or compounds containing silver in order to balance out that equation. So let's balance that out. Okay, so they're saying that we began with 75 grams of silver nitrate and 45 grams of copper. Okay, if the mass of products created was 115 grams, what was the percent yield of the experiment? So they are telling us that the 115 grams is what was actually made. So how do we figure out our theoretical amount? Well, there's a couple ways that you could do this. We could do the stoichiometry of it and turn all of those into t-charts. However, we know the law of conservation of mass. And if I start off with this much in our reactant side, it has to equal the combined amount of our products. So 45.0 plus 75.0 gives us 120 grams. So it means the total amount should have been 120. But since they only made 115, that means my percent yield is going to be 115 grams divided by 120 grams times 100%. And so when you do that, you get that your percent yield is 95.8%, which is a very good percent yield. Very high and very close to 100. Now, remember, one thing that you might have to do in our theoretical yield, which I'm realizing now I did not put an example of this on here, is you might actually have to calculate the theoretical yield yourself. So in example number 2, we use the law of conservation of matter to get it, but in example number 1, they gave it to us, right? They calculated it. And so one thing, though, is since they gave us 50 grams of copper, what we could have done was said, okay, if I have 50.0 grams of copper, we could have converted it using the molar mass of copper, so 63.55 grams of copper for every 1 mole of copper. And then since our conversions, we have 1 mole of copper for every 2 moles of silver, we could have used our mole ratio. So 1 mole of copper for 2 moles of silver. And then the molar mass of silver, so 1 mole of silver for every, I can't remember it off the top of my head, I don't have a periodic table, but the grams of silver could go right here from our periodic table, and when we did this t-chart, that would give us our theoretical amount. And so that is something that you might need to do in one of your practice problems. So for example, let's see, this one you'll need to do that. So, yep. Just notice here that it does tell you like which chemical that they want. So your grams in your formula should always be of a product. So keep that in mind.